In this video, we're going to talk about how we can graph quadratic functions given an equation in either vertex or standard form. Remember that vertex form could also be referred to as a standard form of a quadratic function, and the standard form we're talking about here is standard form for a polynomial. So we're going to look at one example of each and refer back to the previous videos about how we can find these key points on a graph given an equation for vertex or standard form. So in this case, we've got vertex form because we have some quantity x squared. And so the first thing I want to look at is, what do I know about my graph before I even do any work? So first off, this a value here in front of the parentheses, I look to see if that's positive or negative. Since it's negative, I know that my graph is going to open down. That's not enough to do anything with my graph yet. So I want to keep going, try to find more parts of my graph. I personally like to start graphing as I go, but obviously you can find all the information first, make sure it fits together. So the other thing I notice is that since it's in vertex form, I know the vertex. This number here, the opposite sign is my x value. So since it's x minus 3, I have the vertex positive 3, comma, positive 8. So now I can go ahead and graph a part of my vertex, or my graph, I should say, which is going to be just one above my graph here. So I'm probably okay to just put a point right there. If it was any higher, I would want to label where that point is. But that one's fine right there. So 3, 8, and I know it's going to open down. So it's going to come down here. So next thing I can do, well, this obviously, since it opens down, that tells me that it's going to be a maximum point on my graph. We're not going to have a minimum. My domain, I know, is always going to be all real numbers for a quadratic function. And my range, because this is a maximum, starts at 8 and goes down to negative infinity. So I have negative infinity, comma 8 for my range. Now, my y-intercept, I like doing that one typically before x-intercept because I just have to plug in 0 for x. I know that my y-intercept is always going to have an x value of 0. So I go ahead and plug in and evaluate f of 0. This is going to be just negative 3 squared is 9 times negative 2 is negative 18 plus 8 gives me negative 10. So this is going to be a point that's off my graph. So if you're kind of running out of room there, I can just put the point just off my graph. And I know that's not at negative 10, it's not accurate, but if you're not able to draw it accurately, you can go ahead and just put negative 10 as a label on your x-axis, your y-axis. So now I know my graph starts here and it's going to cross my y-axis here, but I don't know where it crosses my x-axis, so I have to find my x-intercept there. I got to remember that x-intercept, my y value equals 0. Well, if I plug in 0 here, I can just solve for x, since I only have one x in my equation. The other forms, you might see x more than once, so we'll have to solve it a different way. So I go ahead and substitute 0 in for f of x, and now I just have to solve for x here. So if I do my opposite order of operations for solving, I end up subtracting 8, and then I have to divide by negative 2. Square root on both sides, and I have to remember that that's going to give me plus or minus 2 when I take square root of 4. Add 3, so now I'm doing positive 2 plus 3 and a negative 2 plus 3. So So that's going to get me 5 and 1 as my x-intercepts, or my roots, my zeros, whatever you like to call them. So I have an x-intercept at 1 and at 5, and that makes sense because my vertex has an x value of 3, and that's halfway between 1 and 5. And now I'm just going to go ahead and draw parabola, and this might represent how you might graph it on a test. Doesn't look very pretty, right? But as long as you clearly have these key points, and you can see on the graph with your scale where those points are, or you have them labeled like my y-intercept here, and that's probably okay. All right, so it's a little sloppy, but again, you can kind of see where all those points are pretty easily. Now, our other examples with standard form. So again, I want to go through and figure out what are my different parts of my graph that I can easily see from my equation without any work. I know that it opens down because we have a negative a value for my x squared term. If it opens down, I know that I'm going to have a maximum value. It doesn't give me vertex or my x-intercepts, but I remember that this c value here is my y-intercept. Because if I plug in 0 for x here and here, it basically makes both these terms 0, and we just get 1. My domain is all real numbers. My range, well, I know it's going to be negative infinity up to my maximum y value, but I haven't figured that out yet. So I got to do a little work with my x-intercept and vertex. Well, my x-intercept here, I can't just plug 0 in here and solve for x because I have an x squared term and an x term. I want to see if I can factor it. Well, I don't like this negative here, so I could factor a -1 out front and see what's left. But when I try to factor that, I don't get anything that works. So if that's the case, then we have to go to quadratic formula, which we remember is this formula here. So we just go ahead and plug in -1 for A, -2 for B, and 1 for C, and evaluate that. So I'll just show all my work here. We end up with, well, we eventually get here. And remember to factor radical there. We want to factor out perfect squares, so we can take out square root of 4, which is 2. So we get 2 root 2 there. Remember that this is one term, and then we've got this 2 here. So this is kind of like a 2x, I always think about. So 2 plus 2x, I can divide the 2 out of there, but this 2 inside is a different expression. So it's kind of like a variable. So I can take this 2 and divide by 2 and simplify it to -1 plus minus square root of 2. So that's going to be a little difficult to accurately graph. I know square root of 1 is 1, square root of 4 is 2. So square root of 2 is in between 1 and 2. So it's a little bigger than 1. So if I have -1 plus a number just bigger than 1, that's going to get me a little greater than 0. So I can just put an approximate point there. And then -1 minus a number that's slightly greater than 1. That's going to give me slightly greater than -2. Okay, so that's right there. So I know my line of symmetry. Well, this is the same value here, right? And we're adding and subtracting it from -1. So that tells me my line of symmetry is probably, or should be at -1. Right, so that's going to be part of my vertex. So that's one way you can at least get started with the vertex. But if we don't remember that, we can just do our x equals -b over 2a. Remember, that's kind of part of our quadratic formula here. So we plug in those a and b values and evaluate. We get a positive 2 divided by negative 2, which is negative 1. And that matches with what we found here. I got to find my y value. I know that it opens down, so my vertex must be above my x-axis here because it's got to go through these zeros right here, or my roots. So I'm going to go ahead and substitute negative 1 in and evaluate that. And we get negative 1 plus 2 plus 1. So we get a y value of 2. And that's my vertex there. So I'm going to go ahead and graph negative 1, 2. Okay, so now I can see that if these 2 points need to be connected, my y-intercept must be above my x-axis here. And it indeed is a positive 1, which I didn't graph right away. So those are my key points. The only other thing to talk about is the range, but I don't need that to graph. Again, even if your graph is really sloppy when you draw it, as long as these points are accurate, then you should be good. So going back to my range, my vertex is at a y value of 2, so it's from negative infinity to 2.